All right, y'all. So here we go. Question number one wants us to graph the equation by plotting points. And they're giving us 4y plus 2x equals 4. So I'm going to actually work it out by hand, and then I'll come back and we'll plot it into our math lab, okay? All right, so whether you use the calculator for the graph or do this by hand, you want to solve this for y. So to solve this for the y, we're going to subtract 2x so that we can move it to the other side. So y'all, that'll give us our 4y on the left side. Those x's cancel. Now, I usually put my x's first, but it don't matter. But I'm going to actually put the x's first and do a negative 2x and then bring down my plus 4. So now my last step is to divide everybody by 4 so I can make that a 1y. Hey, y'all, so this 4 divided by 4 gives me 1y. Negative 2 over 4 won't divide, but we can reduce a negative 2/4 to a negative 1/2 x. And then plus 4 divided by 4, which is 1. Okay, so by hand, you can come in and pick you a couple values for x. So for this one, I would probably let x equal 0. And then since I got a fraction, my second x, I'm going to let be a 2. So if I put a 0 in, 0 times negative 1/2 is 0. And 0 plus 1 gives me a 1. Then I'm going to put my 2 in. And I'll actually show you what's happening when I put the 2 in. So I got negative 1/2 times 2 plus 1. Well, the reason I chose the 2 is because those will cancel. And I'm left with a negative 1 plus 1, which will give me 0. So the 2 points I'm going to plot in MATLAB are 0, 1, and 2, 0. Number 1, this one will be a straight line, so we'll use the line tool in MATLAB, okay? All right, now before I do that, we're going to do it on the calculator. So remember, you have to at least have it solved on the calculator. So I'm going to go to y equals. I'm going to put in my negative 1/2. So negative 1 divided by 2 x, and then we had plus 1. So at this point, if you want to, you can hit the blue second button and the graph button, and that'll pull up a table. So y'all, I had 0, 1 for my x and y, and then I had 2, 0 for my second point. Notice if you don't get numbers that'll cancel the fraction, you have to graph decimals, okay? All right, so either way, you can get your 2 points from the calculator or by hand. And y'all, let's go graph these on MATLAB now. So I'm going to click to enlarge the graph. I'm going to choose the line tool. My first point was 0, 1, so I'm going to go to 0 and up 1. My second point was 2, 0, so I'm going to go right 2 and stay there for 0. At that point, you got your 2 points plotted, you got a line, so you save that, and then we go to the next problem. All right, y'all, so let me write this one down. This one is y equals x squared plus 4. All right, so let's go work this one real quick, and then we'll come back and plot it. The thing on this one is the x squared graph. X squared graph uses the 3-point quadratic tool. And y'all, all you got to do is find 3 numbers that you don't mind squaring. Okay? So 0's easy, 1's easy, 2 is easy. Me, I actually use a -1, 0, and 1. Those are the three numbers, smallest numbers you can get when you square them, okay? So here, if you put a -1 in, -1 squared is 1, and 1 plus 4 gives you a 5. Remember, any number you squared becomes positive, okay? Whether it's negative or positive. So I put the 0 in. 0 squared is 0. 0 plus 4 gives me a 4. Then if I put the 1 in, 1 squared is 1. 1 plus 4 is 5. So y'all 3 points on here. And we can also do this one on the calculator. So let's go to the calculator first. So I'm going to go to y equals, clear off my old graph, and I'll put in my x squared plus 4. All right, so we can go look at that table by hitting second graph. So y'all, I started at -1, so let me go up one more. So there's my -1, 5. Then we got our 0, 4, and our +1, 5. So if you want to see what the graph looks like before you actually graph it, you can hit the graph. So it looks like a parabola, and it looks like it's crossing the x-axis at about 4. So we want our math lab to match that. So we're going to click to enlarge graph. We're going to choose the 3-point quadratic tool. And then just plot our points. We had -1 up 5. I had 0 up 4. And then I had 1 up 5. So y'all, you plot them 3 points. There's our parabola. Looks just like the calculator. So I'll save that and move on to the next. So 3 is absolute value. Y equals absolute value of x plus 5. Y'all, this is the one that's going to be picky. So this one will be a 2-point absolute value tool when we graph it. Now, here's the thing you got to do on this one. The first x value I pick has to make this equal 0 inside the bars. So basically, whatever number that's in there, you're going to put the opposite for your first x. So since I got a +5, my first x would be a -5. Okay? Because that way, when you put -5 plus 5, that's 0. Absolute value of 0 is 0. So remember that. The first point must have a y value of 0. Now, you can pick any other point you want. I could do a -4. So you often put a -4 in there. -4 plus 5 is 1. Absolute value of 1 is 1. Remember, anything that comes out of this absolute value will be positive for the y values, okay? All right, y'all, so that's on hand. Let's go to the calculator. So on the calculator, I'm going to go to y equals and clear that out. So to get absolute value, you hit math and you arrow right until the number is highlighted on top. And your choice number 1, ABS, you hit enter. That's absolute value. And then you're going to put in your x plus 5. All right, so we now got the absolute value of x plus 5. I'm going to go to second graph to look at the table. So you see, I don't see a y value of 0 yet, so I would have to arrow up. So my numbers are getting smaller. So right there is the y value of 0 at -5 for the x. make sure the first point you plot is that -5, 0, okay? Now to look at what the graph is going to look like, y'all look at that. It's a V and it's touching the x-axis over here at -5, okay? Now I'll show you why you have to do that point first when you look at this graph. So I'm going to click to enlarge graph. I'm going to choose the absolute value tool. So you see what it says? It says click to graph to plot the vertex. That's the one that has the y value of 0. That's that little V point. So ours was -5, 0. So we come left to -5, 0. Click that. And then it says plot another point. So I had -4, 1. So I'm going to click that. So y'all look at that. It made the V-shaped graph touching the x-axis at -5. So we save that and click next. So this one should be on y'all. Let's see. Y'all can see that. You got your domain is -4, 1, and 6. They're all pointing to the range value of number 4. So y'all, is this a function or not? So yes, good job, y'all. This is definitely a function. All these x values only have one y value. So we would say yes, because each element in the domain corresponds to exactly one element in the range. Now watch out, they sort of like to make that in backwards and do the range versus the domain, and then they'll switch it and do the domain for the range. So just be careful. We need the one that says each element in the domain corresponds to one element in the range. All right, y'all, so then you would click next. All right, y'all, so for number 5, they're giving us f of x equals 4x squared minus 2x. They want us to find f of 0, f of -1, and then f of 2. So many ways you can do them. You can do them by hand, or you can do them on your calculator, okay? I'll probably just knock these out by hand real quick. So f is 0, put a 0 in for the two x's. You got 4 times 0 squared minus 2 times 0. But y'all, you can punch this right into the calculator like I got it, and it'll spit them out quick. All right, so 0 squared is 0. 0 times 4 is 0. So that all equals a big 0. Minus 2 times 0 is 0. And y'all, 0 minus 0 gives me a 0. Then I put in my -1. So 4 times -1 squared minus 2 times -1. So this -1 being squared, -1 times -1 is a +1. So that gives you 4 times 1 minus 2 times -1. So I just did the exponent first. Now I'm going to multiply this and I'll multiply this. So 4 times 1 is 4. Right here, you're subtracting a 2 times -1, which is going to make that a +2. All right, so 2 negatives will make that a positive. And then y'all, 4 plus 2 gives us 6. So f of 2, that'll be 4 times 2 squared minus 2 times 2. So I'm going to do the exponent first. So I bring down that 4. 2 squared is 2 times 2, which is 4. I'm bringing everything else down. All right, so I'll multiply this and then I'll multiply that. So 4 times 4 is 16. Minus 2 times 2 would be minus 4. And y'all, finally, 16 minus 4 is 12. Okay, so either way, if you want to do them on the calculator, you can punch them in on that and do that. So y'all, you would put in the 3 answers, 0, 6, and 12. Throw in them 3 answers and hit next. All right, y'all, so let me make this one just a little bigger here. And all I want to know, y'all, is that graph a function? So let's see. So I got a yes and a no. So y'all remember this. To be a function, this graph has to pass the vertical line test. So remember, vertical lines are straight up and down, and the vertical line cannot intersect that graph more than one time. So y'all, good job. If you drew vertical lines down through here, it's going to hit it on top and hit it on bottom. That means that you got X values that are getting 2 different Y values, okay? So that one is definitely going to be a no. So good job, y'all. So on that number 6, think vertical lines, okay? All right, y'all, let me write this one down. 7 says g of x equals 8 divided by 8 minus 7x. So they want us to find a domain, and look, they got all the answers in set builder notation. So remember, when I find a domain, I'm only worried about that denominator. That denominator cannot equal 0. So what we do, we take 8 minus 7x, and we set it equal to 0. That way we can find the number that we got to exclude, okay? So I'm just going to solve this. I'm going to move the 8 over by subtracting. So that'll give me a negative 7x equals a negative 8. Then we divide both sides by negative 7. So y'all, that all cancels, making that a positive. That's going to cancel, making that a positive 8 over 7. So we want the one that says x such that x is a real number and x cannot equal 8 over 7. They got to be careful. They're giving you different symbols on that, but we want the not equals, okay? So let's see. X is a real number, not equal to, so it looks like A for me, right? C, they got the greater than. Well, that's not true. D, they just got the 8 there. So we need to go with A on that one, which has got what we want, and then hit next. All right, y'all, let me write this one up. F of X is negative 18x plus 9. G of X equals x squared plus 13. They want us to find f of 0 divided by g of 0. So really, this is just one where you're going to plug in. You're going to plug in for 0 for your x's, and this one's doing division. So I'm going to put my f on top. F is 0 will be negative 18 times 0 plus 9. G of 0 will be on the bottom. Well, that's going to be 0 squared plus 13. So we just plug in 0 since that's what they're giving us for values. And remember, that's division. So I put F on top, G on the bottom. Well, y'all, 18 times 0 is 0 plus 9. That's going to give me a 9 on top. 0 squared is 0 plus 13 gives me a 13 on the bottom. And y'all, I'm looking at that and we cannot simplify that answer any further. So we'll go to MathLab and put in our fraction. So we hit the fraction, and that's what, a 9 over 13. Okay, so we punch that in and hit next. All right, y'all, so what's this, number 9? Let's see what they're giving us. F of x equals negative 2x plus 4. G of x equals x squared minus 2. They just want us to find G minus F of x. Now, y'all notice, they're not giving you any numbers for that x on that G minus F of x. They didn't give us any numbers. So that means you cannot simplify this into a single number since they didn't give us a replacement here, okay? So all we can do is simplify this. So I'm going to do my G minus my F. That's the order they're giving us. G is x squared minus 2. F is a negative 2x plus 4. Now, y'all, subtraction is the one where you definitely got to distribute that subtraction to get rid of these second set of parentheses. So the first set I can bring out, x squared minus 2. There's nothing in front of the parentheses, so they're going to come out just like they look. But y'all, what are we going to get here? We got a minus negative 2x. That's going to make that a positive 2x. And then minus a positive 4. That's going to make that a minus 4. So distribute the negative. And at this point, you're going to add like terms. Now I'm just going to put mine in order. I'm going to put my x squared first. Then I'm going to come in and grab that plus 2x. Then I'm going to add that negative 2 and that negative 4 and get a negative 6. At that point, I have no more like terms, so I'm done with my answer, okay? So y'all, for MathLab, we would do what? X squared, arrow down, plus 2x minus 6. Okay, y'all put that answer in and then hit next. Now, y'all, this one's the same thing basically, but notice on this one, they are giving me a number to put in. So let me write that down. F of x equals x squared minus 16. G of x equals 15 minus x. They want us to find f minus g of a 0. All right, so I'm going to show you how I put that one in. So f minus g of 0 will equal my f minus my G. But I'm putting zeros in for the X's. So I'm going to have F, which is 0 squared minus 16, minus my G, which is 15, minus 0. So they gave me a 0. I put a 0 in for my X's. Now this one I can just do a little order of operations. 0 squared is 0. And I get 0 minus 16, which is a negative 16. Then I got my minus. 15 minus 0 gives me 15. So basically, negative 16 minus 15 gives us a negative 31. So remember, like signs, add and keep them negative, okay? All right, so that was what, number 10, and we put in what, a negative 31. Oh, y'all, what we got here? Oh, domain. So let's see if y'all remember this one. Um, so let me write these functions down. What's this, number 11? So let's see, f of x equals 1 over x minus 1. G of x equals 6x to the third. So we're going to find the domain of the sum, difference, and product. And y'all, I don't know if you remember, but on this one, adding, subtracting, and multiplying will always have the same domain. So if we can get one of these, we'll get all three of these, okay? So adding will be f plus g of x. That'll equal my f, which is 1 over x minus 1, plus my g, which is 6x to the third. All right, now let's get our domain. Well, let me ask you this. Do y'all have anything we're going to exclude from this domain? Or will this domain be all real numbers? So y'all, there is definitely a fraction. That's what we was looking for. So we was looking for the fraction. So we know that the bottom of this fraction cannot equal 0. So you would technically set x minus 1 equal to 0. Solve that by what? Adding 1. So since I get a 1 on that, what do you got? X is a real number and x cannot equal 1. Perfect. So x such that x is a real number and x cannot equal 1. Now, y'all listen. If I change that to a minus, it's the same thing. This minus this, I'm still worried about that fraction. If I change that to multiplication, I'll have this times this. I'm still worried about that fraction. So all three of those will have the same domain. Okay, so if you can figure out the first one, you've got all three on that question. All right, y'all, so I'm gonna come in here. X is a real number and x cannot equal 1. Then I'll come down here. X is a real number. X cannot equal 1. And then finally on the third one, X is a real number and X cannot equal 1. Y'all, those three will have the same identical domain, okay? Now this is one giving people a little bit of fits on the on the ones that I've seen doing the review and in the homework. So this is f of x equals 9x minus 7. G of x equals 7x minus 42. But y'all look up there, they want to know the domain of f divided by g. Okay, so the domain of f divided by g. All right, so I would come over here, f divided by g equals the f on top, which is 9x minus 7, over my g, which is 7x minus 42. Now, y'all listen. Once again, I don't care about the top. It's just that bottom. So since we do have a denominator with a variable, you would set 7x minus 42 equal to 0. Whatever answer we get, we're going to exclude. So y'all a message, so y'all are getting not equal to 6s on those. So, whoops. That looks good, Nat, because what we would do is add our 42, and I get my 7x equals 42, and then divide by 7. So that I get my 1x is 6. So remember in the domain, x such that x is a real number, and x cannot equal a positive 6. So that's the one where they do the division. The number 11, they're just worried about adding, subtracting, multiplying. But number 12, they do hit you with the fraction. So set that bottom equal to 0, okay? And then find that number. So over here, we would put x is a real number, and x cannot equal, what do we get, a 6, okay? Yeah, that's what I'm saying, Katarian. That's what got you on my review, okay? So we'll fix you on the test. How about that? Also, whoops, hit next. Oh, so this is where we started doing the compositions of functions. So y'all let me write that down. 4x plus 5 is my f. G of x is x to the third. They want me to find f compose g of a negative 2. All right, y'all, so let me go share that. We'll work that out. So remember, this is like f of g of negative 2. I'm going to put negative 2 into the g first. Once I get that answer, I'll put it into the f. So we're going to find g of negative 2 first. Well, that's just putting the negative 2 in for that x, so that I got negative 2 to the third power. Oh, y'all, so negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. So since g of negative 2 is negative 8, we now find f of that negative 8. Right, so we're going to put the negative 8 into our f, which will give me 4 times negative 8 plus 5. All right, y'all, so let's see. 4 times negative 8 is negative 32 plus our 5. And that's what, a negative 27. So in Math Lab, we just put our final answer of negative 27. Okay, so notice when it do give you replacement values, you will get an answer. When they just throw an X there, You're just really just able to sort of simplify it, okay? All right, y'all, look, it says use the horizontal line test to determine if this function is one-to-one. So y'all, my question is that function one-to-one? Does every y value only have one x value? So y'all are giving me no, good job. Y'all, because if you run a horizontal line across that, it's going to hit it at least twice, okay? So that's definitely a no. Good job, y'all. So we would click no on that one. So remember, vertical line for functions, horizontal line for one-to-one. All right, y'all, we would hit next. Now, let me write this one down. What are they giving me? F of x equals 8 over x plus 2. Well, guess what? It is going to be one-to-one. So on number 15, and I give you a function to find the inverse, you better put yes on, is it one-to-one? They are all one-to-one, okay? So we're going to go find an inverse. So let me go to my pad. So y'all, to find the inverse, I replaced this f of x with a y. Do y'all remember what I did next in order to find my inverse? And it's probably the most important step I can do. Oh, y'all let me get you. Remember, since it's an inverse, at this point, I switched the x into y. That'll give me x equals 8 over y plus 2. So y'all remember, replace the f of x with a y, then switch them. And at this point, we're going to solve for the y. So usually what I do to solve this one, I'm going to multiply both sides by y plus 2. So y plus 2 times x equals my 8 over y plus 2 times y plus 2. Now, the reason we do that, because it cancels it out on this side, and you're just left with the y plus 2 times x over here. So y plus 2 times x equals 8 at this point. Now, I'm not even going to distribute this because I'm solving for the y. So at this point, I would divide both sides by the x so that this x cancels. So all that's left is y plus 2, which means I no longer need the parentheses. Y plus 2 will equal 8 divided by x. Now y'all look at this. All I did, this x and y plus 2 basically just switched places so that I got the y plus 2 up here and the x down here. And y'all, my last step, subtract 2 from both sides. So that's going to cancel, giving me my y equals 8 over x minus my 2. Okay? And then remember, the last step would be to turn the y back into the f inverse of x notation. But y'all, all we got to do is put that into the answer blank because MathLab is already going to give us, if you notice here, they've got the f negative 1 of x. So we're going to put in our fraction, which was a 8 over x, and then arrow out of that and put in a minus 2. Y'all is going to look really similar to that. It'll be something over x plus or minus some number on that, okay? Oh, y'all, let's see. This is number what, 16? Solve by the elimination method. 5x plus 4y equals 52. 4x plus 5y equals 56. So y'all, let me ask y'all this. Anybody working these by hand, or are y'all doing them all on the calculator? So y'all let me know so I know which way to go. So I got people working these by hand. So I will actually do this by hand then, okay? Now remember, you could do a 2x3 matrix on the calculator and do all that fun stuff. But we're going to work these by hand. So let me get my page wrote. Oh, I'm trying to get my focus in real good. Let me try something else. It's a little out of focus on my end. All right. All right, there, that's better. All righty, so, well, I guess the first question is, what do y'all want to eliminate, X's or Y? And hell, they look about the same to me, don't they? So y'all want to will X's? Okay, we're going to eliminate X. So to eliminate X, what number can we turn both of these into if I'm going to eliminate that X? So y'all, it looks like the smallest number that 4 and 5 can turn into, that they're both factors of, would be 20, right? So I'm gonna make one of these a negative 20, one of these a positive 20. So I'm gonna keep the top positive and multiply that whole row by 4. That'll give me a positive 20. The bottom row, I'm gonna multiply by negative 5, and that'll give me a negative 20 for that row. So let's do the first one. 4 times 5 is 20x, plus 4 times 4 is 16y, and that's 4 times 52, which is what, 208. Okay. Now my bottom row, negative 5 times 4x is a negative 20x. Negative 5 times 5 is negative 25y. And then I got negative 5 times 56, which is a negative 280. All righty, y'all. So I'm going to add them together, but the x's cancel like we wanted. 16 and negative 25 are going to give us a negative 9y. And then that negative 280 and 208 give me a negative 72. So we got one variable left. We're going to divide by negative 9 and see what our y equals. So y'all, that cancels. Y. Those negatives are going to make this side positive. And what's that? 72 divided by 9 gives me an 8. So we now know y equals 8. So we're going to back substitute. And remember, you always back substitute into the system where you got your answers. So I'm going to back substitute into one of these two. So I know my y. So I'm going to use the first one. I know that 5 times x plus 4 times y, which is 8, that has to equal 52. All right, y'all. So 5x plus 4 times 8, which is 32, equals 52. So now we're going to do a little subtracting. Subtract our 32 from both sides. We all that 5x comes down. 52 minus 32 leaves me 20. And y'all look at that. One more step. We know our x. So we divide everybody by 5. So x equals a positive 4. Now remember in Math Lab, you got to put them in ordered pairs and do your 4, comma 8. So if we go back to Math Lab and look at it, notice it says under that type an ordered pair. So we want our parentheses are 4, comma 8, and then close parentheses. Okay. All right, y'all. Then we what? Hit next. All right, so let me get more paper over here. Oh, so we're solving the big system here, right? So for 17, I got 5x minus y plus z equals 34. 3x plus 2y minus 3z equals 7. And then I got x minus 3y plus 2z equals 15. All right, so I'm gonna call this, remember I called this 1, 2, and 3. Sort of keep up with our equations here. So this will be my equation 1, equation 2, equation 3. So are we doing this one by hand? Also, all right, so I'm getting one by hand. So, all right, on calculator, this would be a 3 by 4 matrix if you were doing it by calculator, okay? So, y'all, the first thing, I guess we need to figure out what variable can y'all eliminate. And y'all, none of them look too bad. So, what do y'all want to go with? The X's, Y's, or Z's? So, Eva, how about you? What you want, X, Y, or Z? Okay, so it looks like I'm getting some X's on there. So, y'all, I'm going to eliminate the X. So I notice I got a single X here. So what I'm going to do first, I'm going to eliminate this 5x by multiplying this row by negative 5. So I'm going to multiply 3 by negative 5. And then I'm going to add to equation 1. Okay. So I'm going to multiply this one by negative 5. So I didn't change 1, so I'm going to bring it down. 5x minus y plus z equals 34. This will give me a negative 5 times x is negative 5x. Negative 5 times negative 3 is a 15y. Negative 5 times 2 is a negative 10z. Negative 5 times 15 is a negative 75. All right, Jackson, so good job. The x's are canceling. 15 and negative 1 give me 14y. 1 and negative 10 give me negative 9z. And then let's see, 34 minus 75 is what, a negative 41. So this will be my equation 4, which is the first equation of my two variables. So y'all, we used 3 and 1 that time. Now we got to use this equation. So since I just had an x here this time, that's a 3x. I want to make that a negative 3x. So I'm going to multiply the third row by negative 3 and add the row 2. So I'm going to multiply 3 by negative 3 and then add to equation 2. That way all three of these are being used, okay? So I'm not changing 2, so I'm bringing that down. 3x plus 2y minus 3z equals 7. This I'm multiplying by -3, so -3x. -3 gives me a positive 9y. -3 times 2 gives me -6z. -3 times 15 is a -45. But y'all look at that. X is canceled like I needed. 9 and 2 give me 11y. -3, -6 is a -9z. -45 and 7 is a -38. That'll be my fifth equation. But y'all remember, these two equations now make a 2 by 3. Now, y'all, I know what variable I'm about to eliminate. These 9z's look pretty close. All I got to do is multiply one of these by -1 and cancel those z's out. So what I'm going to do, I'm going to multiply bottom equation by -1, and then I'm going to add to my top equation. So the top one stays the same. 14y minus 9z equals -41. All this -1 is doing is changing the signs. So I get -11y plus 9z equals a positive 38. All right, y'all, so let's see what we get. 14 minus 11 leaves me 3y. The z's cancel. And that's going to equal -41 plus 38, which gives us a -3. So at this point, we can solve for y by dividing both sides by 3. And all that cancels, giving me my y equals unlike signs. So that's going to be what, a -1. So all of that work, we now know what y equals. So I'm going to back substitute into one of these equations and solve for the z, okay? And it don't matter which one. So I'm going to back substitute. I'm going to do this one here. It 14 times y, which is -1, minus 9z has to equal -41. So y'all, that gives you -14 minus 9z equals -41. We're going to add 14 to both sides. So y'all, -9z equals a -27. And y'all look at that. We divide by -9. That gives me a 1z. Negative divided by negative makes that a positive 3. Well, I know y is -1. Z is 3. So I'm going to go back into one of these three equations and solve for the x. So y'all probably use that top one, okay? So I got back substitute for the last time. I'm going to do the 5x minus y. So that's minus -1 plus my z, which is 3. Oh, that's got to equal 34. Oh, y'all, we'll bring down the 5x. That's subtracting a -1 makes that a +1. And then plus 3 equals 34. So I'm going to add like terms. 5x plus 4 equals 34. Notice now we're going to subtract and divide. So we'll subtract 4. We get 5x equals 30. And y'all guess what? Our final step, divide both sides by 5. So 5x divided by 5 equals 30 divided by 5. That's going to cancel, giving me my x equals positive 6. So that answers an ordered triple. 6 for the x, -1 for the y, and then 3 for RZ. Okay? All right, so yeah, you had me on there already. 6. Exactly. Good job. All right, y'all. So let's go put that in. Now, this one, they already give me the parentheses, so we just got to put in our numbers. 6, -1, and then a positive 3. Okay? Oh, y'all, it's break time, so let me pause this for just a little bit. All right, y'all, let's do our 10-minute break. So what is it? It's almost 11. So looks like I'll see y'all at about 11:07, okay? That'll give us our 10-minute break, and then we'll come back and knock this out. All right, y'all, so take 10. You welcome. You just look at it. Everything gonna be good with you in again. That's all one. Anyway. Okay. We'll have a quick one. One second. Well, All right, looks like everybody's back, so let me record. All right, y'all, so we're going to graph the inequality 2x minus 3y less than or equal to -9. So no matter which way you solve this, you got to solve it for the y, okay? So we need to solve that for the y first. So we're going to move the 2x over by subtracting. So y'all, that cancels, giving me my -3y is less than or equal. And then once again, I'm just going to put my x first and do -2x minus my 9. Now, we got to divide everybody by -3. But remember, this is an inequality. So when we divide by -3, we need to reverse the inequality so that it is now greater than or equal. All right, also that cancels, giving me my y greater than or equal. All these negatives are making everything positive. So I'm going to get a 2/3 x. And then minus that 9 divided by -3 makes that a +3, okay? So at this point, I would find my 2 points. So I'm going to use 0 again. And then remember, I got a fraction, so I'm going to use 3 for my next x. So if I put a 0 in, 0 times 2/3 is 0. 0 plus 3 gives me a 3. Now, if I put that 3 in, I'll have 2/3 times 3 plus 3. Those 3's are going to cancel. And I basically have 2 plus 3, which is 5. So when x is 3, y is 5. Now, y'all, you can put this part right here in your calculator and then go to the graph, the table, and you'll see all kinds of points you can use, okay? So I've got my 2 points. Now, since there's equals here, I'm going to use a solid line. And since it's greater than, I'm going to shade above. Okay? So let's go to Math Lab and put that in. So click to enlarge graph. This is a line, so use the straight line tool. By default, the solid line is already highlighted down here. So we just need to plot our 2 points. We had 0, 3. And then we had right 3 and up 5. So I got my 2 points. My line is solid. So now grab that paint can, and we said we're going to shade above the line and click. At that point, you would save your graph and move to the next. Now I'm going to show you that one on the calculator real quick. So let me go to my calculator. I'm going to go to y equals and clear this out. So I'm just going to put in my 2 divided by 3x plus 3. Now remember, I'm going to go all the way left and highlight and hit enter. I'm going to shade it blue. Greater than was the triangle that's above like this. I'm going to come down and hit OK. So now when I hit graph, y'all, there's the exact same graph we just drew. And then, like I said, second graph, you could have went and got your points, okay? So there's my 0, 3, and then there's my 3, 5, okay? All right, y'all, so we would hit next. So 19x greater than 3. So really on this one, we don't have to do no work. Remember, when it's x equals a number, x greater than a number, x less than a number, this is a vertical line. So all we got to do is go click our graph. Now notice, there's not an equals under that. That is just a greater than. So you would come down and click the dotted line. Okay, if you use a solid line, it will mark you wrong. So use the dashed line, click the line tool. Now remember, x3, you go to 3 on the x-axis, plot a point, and then you can go up or down to any other y value for that point. So I'm just going to click here. It made me a vertical line through 3 on the x-axis. Now, this is greater than. So would y'all shade to the left side of that line or would y'all shade to the right side of that line? Which way did those x's get greater? Left or right? I'm going to shade to the right. Good job. Remember, any x value on the right side that is shaded, all these x values are greater than that x value of 3 there. So y'all just remember that. 19 is a vertical line, okay? It goes through the x-axis at that point. Oh, y'all, so then we hit next. And I think the last one is a system of inequalities. So you're going to graph both of these, and you're looking for the double shaded section. So let me write these down real quick. So I'll do this by hand, and then we'll knock it out on our calculator. All right, so there's my 2 equations, and I'm just going to make a little x and y graph here. So remember, I got to do the x and y for each one of these lines. Now notice, they both got equals in them, so they're both going to be solid lines, okay? And I'm going to pick 0 and 1 for both points for my x's, because I don't have any fractions. So this one I'll plot here. This one I'll plot here. So if I put a 0 in for the x, 0 plus 6 is 6 for the y. If I put a 1 in for the x, 1 plus 6 is 7 for the y. So let me make that go out a little bit. So there's 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0, 6 will be at 0, up 6. And then 1, 7 will be right 1, up 7. So that line was solid. And it was greater than, so it would shade above all this. So now let's plot this one. I'm going to put a 0 in for the x. 4 minus 0 is 4. If I put a 1 in for the x, 4 minus 1 is 3. So this one has 0, 4. So 0 up 4. And then it has 1, 3. So right 1 up 3. So that line is sort of going downhill left to right. It's less than, so it's going to shade below the line. So notice the double shaded area is this section right here on the left side. All right, y'all, so on the calculator real quick, remember. So let me go to y equals and clear that out. So first I would put in my x plus 6. Arrow all the way left. And, well, I've already got greater than highlighted there, so I'm good on that one. On the second one, I would put in 4 minus x. That one was less than, so I'm going to arrow left and hit enter. It's going to draw red. So let me get the triangle that's on the bottom. So there I go. Hit OK and enter. And y'all, when I shade this and hit graph, I'm looking for the double shaded area, which is on that left side again. So knowing that, let's go pick one of these 4 answers. So we shaded on the left side, so we would pick C. Now, I'll tell y'all a little trick on this one. Every time I've ever done this one, it's been the same graph on the left side like that, okay? All right, y'all, so then at that point, you submit it and be done. All right. All right, y'all, so that's your test 1, okay? All righty, so let me see what my chat's saying. Oh, that's all right. That's all right. All right, so I will do 7.1 for y'all. It's not a bad little section. And then tomorrow we'll pick up at 7.2, okay? So this is test 2 material starting now. All right, y'all, so test 2 material starts in 7.1, and we're looking at symmetry. So symmetry is going to have 3 things we look at. Now we're talking about graphs, okay? So a graph can be what we call symmetric to the y-axis. And so remember, the y-axis is my vertical line. So what that means, if it's symmetric to the y-axis, the graph is cut in half by the y-axis. So you can fold the graph over the y-axis. So we can fold the graph over the y-axis and it lands on itself. Also, if a graph is symmetric to the y-axis, we say that it is what we call an even function. Even function because to be symmetric to the y-axis, the highest exponent has to be an even number, like a 2, 4, 6, and so on. So y'all, let's look at a graph that would be symmetric to the y-axis. That'll be our parabolas we've been looking at. Okay, on a parabola, if I took this graph and folded it right over that y-axis, this side of the graph would land on that side of the graph, okay? So that's the y-axis. Notice it cuts it in half. Next, we got symmetric to the x-axis. So basically, it's the same thing. The graph is cut in half by the x-axis. Which means you can fold the graph over the x-axis and it lands on itself. Now, if it's symmetric to the x-axis, it's not an even function or an odd function because it's not even a function, right? Remember, if this was my x and y, and I had a graph that was symmetric to the x-axis here, well, remember, this fails the vertical line test, so technically, it's not even a function, okay? Third one, symmetric to the origin. Now remember, the origin of the graph is that little center in there, okay? That's the origin where the x value is 0 and the y value is 0. But if it's symmetric to the origin, turning the graph 180 degrees, and we get the same picture. Or how about we get the same graph? So 180 degrees would be turning it upside down, okay? Now, if a graph is symmetric to the origin, we say it is an odd function. It'll have the highest exponent of an odd number, okay? So y'all, let me show you one that is symmetric to the origin. That would be a graph that, say, comes up, crosses through the origin, and then goes up like that. Now, y'all look at this graph. It's going uphill left to right. If I turn that upside down 180 degrees, my graph is still going uphill left to right. So turning it upside down gives you the same exact graph. And like I said, these are odd functions. So y'all hang on a second. I'm going to pull up the 5 problems for that and let y'all answer those. So this was 7-1. All right, y'all, so let me get my share on. All right, y'all, so I'll make this bigger. But this graph here, determine if it's symmetric to the x, the y, and or the origin. Well, y'all see the graph here. So I would look at the y-axis. Is it symmetric to the y-axis? Is it symmetric to the x-axis? Is there no symmetry, or is it symmetric to the origin? So y'all, what are we going with? All right, so I'll walk y'all through this. And so notice, if I took this graph and folded it over the y-axis, this right side is humped up. It's not going to land on that bottom side. So it's not symmetric to the y-axis because the y-axis ain't cutting it in half. So then you look at the x-axis. Well, if you fold it over the x-axis, this little hump ain't hitting nothing down there. And the x-axis is not cutting it in half. But y'all look at this. If I took this graph and turned this upside down 180 degrees, this right side would move to the bottom, and then the bottom side on the left would move up to the top on the right. It would give me the same exact picture if I turn that upside down, left to right. So this one is symmetric to the origin. And we would check our answer. All right, y'all. Let's see what they're asking us. Choose the correct answer. Is it symmetric to the x, the y, or the origin? So A says both the x and the y. B says the x. C says the y. D says the origin. So what would y'all pick on this? Is it symmetric to the y, the x, or the origin, or both the x and the y? So Jackson, what are you saying? Y, that's good. Because y'all look, you got a y-axis. That y-axis is cutting that graph right in half. And it would land on itself if I folded it. It ain't even nowhere near the x-axis. And it's not going through the origin, so it can't be the origin. So y'all, that would be only C, the y-axis. Are you going to check that answer? Hey, also, I made that a little bit bigger. So this one goes in order. Is this graph symmetric with respect to the x-axis? Yes or no? So I got a yes for that. Good job. So we hit yes. We check that. Is it symmetric to the y-axis? So it looks like this is going to ask us everything one by one. So y'all, is it, so I'm getting a no on that, and good job. So we click no and enter. Is it symmetric to the origin? So that is definitely a no. See, it's not even going through the origin. It's a little bit far right of that. So that's a no. So you check that. So let's see if y'all remember on this. Is this function odd, even, or neither? So Jackson, that's an even, because remember, even, it's symmetric to the y-axis. And y'all, I'll tell you another way you can check. How many times does it touch the x-axis? Touches it once on the left, once on the right. That's an even number also. So that is definitely even. All right, let me make that a little bigger. Is this function odd, even, or neither? So basically, is it symmetric to the y-axis is even, symmetric to the origin it's odd, anything else would be neither. What y'all going with? Odd, good job, y'all. Because if you took this sine wave, I would call that, and turned it 180 degrees, this graph would look exactly the same. So that makes that a odd function. All right, y'all look at that. That was 7.1. So just a little bit to get you a start on your chapter 7 material. Dealing with a little bit of symmetry, okay? All right, so tomorrow we'll pick up in 7.2, and that deals with transformations of graphs. So we'll see how you can move a graph up, down, left, right, and flip them and all that fun stuff, okay? So the main thing I want y'all to focus on is doing your test 1 review and doing that test 1 before Sunday night. Now, I sent an email last night. It's got bonus points for test 1. So what I'll do, after y'all do test 1, I'll add the bonus to that, okay? So I'm keeping up with who all sending me those answers. It's just one problem to figure out, and you can email me that answer, okay? All right, y'all. So anybody got any questions? And y'all, another thing I wanted to let y'all remember, the test 1 review counts as a quiz grade, and you can do the review as many times as you want. It will keep the highest score. Get good on that before you do test 1, because test 1 only gets 1 attempt on a test. Okay. Now the test is exactly like the review, so practice that review, get good on it, and then do the test. Okay. All right, y'all. So I'm gonna stop my video from recording.